Hi, everybody. We've got the Easter Bunny sitting in our recording today, so you're mostly going to see him. I'll be peeking in. And this is because, hey, Easter's this weekend, so the dog's busy, so I brought you a bunny. What I'm doing today is doing 4 ideal gas law problems from you, so really the focus is on the board. The ideal gas law problems I've got are the practice problem from yesterday, and then the 3 that were assigned to go over today. You have a couple choices on this. You can try these practice problems on your own and then watch the video. You can try them one at a time and pause in between. Or if you like when I go over the problems with you together in class, I know high 5th period, you guys love that. So if you want to go over it like I'm teaching you, just like we do in class, feel free to watch it and work on them with me. We've got the one from yesterday I wanted you to try, and 3 new ones. So there you go. The one up on my board is the one from yesterday. After this, I'm not writing out the problems because you should have them in front of you. I'll be pulling out the variables going from there. And if you have any questions, let me know. For my very first one, and I'm just going to leave you with the bunny now. The room I'm recording in is about literally 5 feet wide, so this is the best I've got. How many moles of air molecules are contained in a 2-liter flask at 0.975 atmospheres and 25.0 degrees Celsius? The first thing I know is that R is always the same. 0.08206 liter atmosphere per mole Kelvin, and the equation I'm going to use is definitely PV equals nRT because I've got moles, liters, temperature, and pressure in atmospheres. 0.975 atm for my pressure. My volume, 2.00 liters. N, number of moles, I do not know. And temperature, it's 25 Celsius. I don't like Celsius. I have to use Kelvin, and I get 298 Kelvin. I want to get N by itself, and you don't have to rearrange ahead of time, but if you do, if I divide both sides by RT, then N equals PV over RT. Since we've got this written down, I'm going to take down the question and show you my work up there. So P, 0.975 atm, V, 2.00 liters, R, always the same, 0.08206 liter atmosphere mole Kelvin, and T, temperature, 298 Kelvin. If I were entering this in my calculator, I would do 0.975 times 2 equals, divided by 0.08206 equals, divided by 298 equals. And when I do this, I'm going to look at significant digits because, again, Google Classroom is getting you guys on those. It's checking for at least close to the right number and your units, too. For this, since I'm looking for a number of moles, my units at the end will be moles. 3 significant digits, 3 significant digits, 3 significant digits, and don't worry about R. So I'm going to do to 3 significant digits 0.0797 moles for that one. 0.0797 moles. Hopefully you got that from the practice problem from yesterday. Now on to today's problems. I'm going to erase down here all but R. Remember, I'm not erasing R because R is always the same. Gas, constant. You always need to use it for ideal gas equations. So let's clean that up and look at the one in your notes. First practice problem. What pressure is exerted by 3.50 moles of gas at 273, and I'm going to double check. Yup, that's Kelvin. I'm good to go there. In a volume of 10.0 liters. PV equals nRT because that's what this whole thing is on. I want to get pressure by itself. If I divide both sides by volume, I can cancel volume here and say that P equals nRT over V. Makes sense. We can even just clean that up. Or you can leave it as PV equals nRT. Put in your values and work from there. It doesn't matter. So I'm going to get N, 3.50 moles. That says moles. Got a little small. 0.08206 liter atmosphere per mole Kelvin. For my R, temperature already nicely in Kelvin, 273, divided by my 10 liter volume. Should set you up. All we're doing is plugging in variables. Even though we might be solving for different variables on different problems, it works the same way. Calculator time, 3.5 times 0.08206 times 273 equals, divided by 10 equals. And I wanted to show you at least one of these problems that it'll cancel out. The units will cancel. Moles and moles on the bottom. Kelvin and Kelvin on the bottom. Liters and liters below the fraction bar will give me atmospheres for my units. I also know pressures in atmospheres, so even if I don't cancel, rest assured that if you use that R, you get atmospheres for your pressure. Looks like 3 significant digits, 3 and 3, so I'll use 3 in my answer. I got 7.84 ATM. I always tell the AP Chem classes when I have new worksheets, and I'll say it to you guys this time too, if everybody's getting a different answer from me, please let me know. I double checked, but because this is the first time I've used this worksheet, there is a risk of mistakes, so don't feel bad if you have questions. If you're like, not even close, I'll gladly explain to you where one of us made the mistake. So no worries, it could be me just as easily as it could be you. The second one, we're looking at temperature here. So let's clean up down here first in case you were still copying, even though pause is wonderful. Let's see what we got. At what temperature? Cool. Does 1.3 moles of gas occupy 2.5 liters of volume and exert a pressure of 2 atmospheres? First thing I notice is I went way short on significant digits this time. I've only got 2 in each one. I'm going to keep 2 in my answer. I also noticed that, hey, like I say at school, same crap, different problem. I'm still on PV equals nRT, but this time I'm solving for T. I want T by itself, so if I divide by nR, those will cancel, and it looks like T equals PV over nR. So P, 2.0 ATM, V, 2.5 liters, divided by everybody's favorite R, 0.08206 liter atmosphere per mole Kelvin. 6th period, at least I'm not looking at you guys going, this is the 3rd time I wrote this today, where I have the answers memorized. There's R, and here's N, 1.3 moles. I switched N and R where I wrote them on the bottom. It doesn't matter as long as they're on the bottom of the equation. So entering this into my calculator, 2 times 2.5 equals, divided by 0.08206 equals, divided by 1.3 equals, and if I look, moles cancel, atmospheres cancel, liters cancel. I've got Kelvin. That's a temperature. That's a wonderful thing. And if you did this or are doing this and you're like, that's code. It is code. And it is only 2 significant digits when I round. 47 Kelvin. Brr. 273 is the freezing point of water. Brr. That's code. So, that's what I've got for the first 2. 1 more to go, where we're calculating a volume this time. I tried to mix it up. Tried to give you a little of different kinds of these where we're solving for different variables, but they're pretty much the same. What volume, I don't know, is occupied by 15.0 moles of a gas at a pressure of 3.00 ATM and a temperature of, look nice again, Kelvin again. All right. PV? Oh, wow. Again, PV equals nRT. I want volume by itself, so I divide both sides by pressure to get volume by itself. nRT over P will give me volume. N. That's a lot. 15 moles. R. Wow. Same old. 0.8206 liter atmosphere. Mole, Kelvin. Every time I write that, it looks more like it says lamp over milk. Good. Temperature, 300 Kelvin. And a pressure of 3 atmospheres. Let's significant digit check. Looks like 3 in all the variables I gave you. Let's unit check. Atmosphere, Kelvin, mole. My answer looks like it's in liters, as a volume should be. This is a pretty big volume because this is a lot of moles there. When I calculate this, enter it in the calculator. 15 times 0.08206 times 300 equals, divided by 3 equals. I get a 123 point something, but to round to 3 significant digits, I got 123, 123 liters. So, from me and the bunny, I hope you had a good lesson on ideal gas law problems today. You're going to have the practice you'll see in your stream due on Tuesday. It's 10 gas laws problems. Not all of them are ideal gas law. In fact, very few are. There are a mixture of the types of gas laws, including one combined gas law question. Got to do it? 10 points, 1 point per correct answer. You guys can work together on them, do your thing. It's like your practices in class. So I want you to turn those in by Tuesday. I know I don't like Monday stuff. So you'll get a chance to work on it. I hope that this weekend you have a nice Easter, whatever you do. At least enjoy the spring, hoping for good weather. Have a great one, and I will see you later, probably without my bunny friend. Have a good one.